All right, here I'm going to show you how to find arc length in this video. Arc length is a formula, and I have the formula up here on top in red. It says x times c divided by 360, with x being the degrees of the arc we're working with, and c being the circumference, and you'll need to know the circumference formula. So this looks a little crazy with all this stuff here, but I'm going to be nice and slow and tell you exactly how to do it. So just bear with me, write some stuff down. So let me tell you the difference between an arc length and a measure of an arc. So an arc length would be, let's say we have a tire here. I take a piece of string, I tie it to the top of the tire, and I wrap the string all the way around the tire. That's a circumference. But what if I only needed to know, maybe we were repairing something and I only needed this much? Well, according to this arc, there is a measurement based on an angle. And that's a measurement of an angle, but there's also a length of this material. So it's as if I took some of this string that I wrapped around, but I only need a portion of it. So basically what an arc length is taking this portion, okay, and then we would straighten it out, and then we would take a ruler up to here and measure it. So that would be the measure of an arc length versus the measure of an arc measurement, like it's measure versus length. It gets a little complicated, but bear with me. We're going to do some examples. I'm going to do my best to help you. So the reason why we have this circumference is easy, but there are two formulas. So it's based on if they give you a diameter, which goes all the way through, and that would be circumference is this 2 times the diameter. Or would be, that should be pi times diameter. I apologize. This is incorrect. This should be pi times diameter. So I'm taking that out, and that should be pi. Pi times diameter. Okay, so pi times diameter, or if they give you a radius, which is half of the diameter, it would be 2 times pi times radius. Okay, so here we go. I'm going to go nice and slow. So if EB is 15, okay, so first, let's take a look at this EB. So EB is 15. Okay, understand what that is. That's a radius. That means I'm using this circumference formula because it gives me a radius. So you just use whichever one they give you. They either give you the R or they give you the diameter. So half or the whole. Okay, find the length of CD. All right, our interest is to find the length of this material, like this string, that I could tie from C to D. So what we need to do is find the degrees measure of the arc. So I need to find the measurement of this arc in degrees by understanding what the degrees of its central angle is, because central angle is equal to its associated arc. So I can do a half circle in here with 68 and get 112. So 112 is our measure, and now we have our first piece is x. So 112 is what we need. So I'm building this equation. Now I need the circumference, and I've already decided I'm going to use 2 pi r. So this is going to be 2. I'm just going to use the symbol for pi right now. And then r, we said our radius was 15. And we're done. We're done inputting what we need. The rest is just pushing buttons. Okay. Let me grab my calculator here. I'm just going to use the pi button for now, which is fine. So I got 112 times 2 times, let's see, where my pi times 15 equals, and then divide it by 360. And I got 29.32, which is fine. Approximately 29.32. I put this exactly in the calculator. 112 times 2 times pi button times 15 divided by 360. Hit equals. That's exactly what I did. Got 29.32. All right, so I went on to copy the next question, and I copied the formulas that I needed off the top of the page, off from the previous page. So here's my copied formula and my copied question. All right, so let's start. It says NR is 8. Okay. So NR is again a radius. So I am going to go with my first circumference formula because that's the one that has a radius. So NR is 8. All right, I need that information. Find the length of NMP. So let's remember how we do this. I start at N, I'm going through M, and then I'm ending at P. So this here is the string we are going to cut and find the measure of. All right, so it looks like we have a little more than half of a circle. Okay, so I want you to see this. See, this is a half circle we can work with right here with this 162. So if I recognize this diameter and I see this 162 here, I can recognize this portion as just being the 18 measurement. That's a measure, it's not a length. So that would be 18 to make the 180. So this would also be 18, this would be 18, and this length would be 18. So it looks like all of this, N to M to P, would be 18 plus 162 plus 18. And that is our X. And I get 198 is the sum of all this measurement, arc measurement. Okay, that's 18, 162, and 18. Now put our multiply sign in. We're going to use 2 pi r. So I'm going to say 2 times pi times my r, which was given to me in the question, all over 360. And the hard part is done. The easy part is pushing these buttons to make sure it works. So I'm going 198 times 2 times pi times 8 divided by 360. I got 27.64. I'm going to do it one more time just to make sure I pushed all the right buttons. And 27.64 works. All right, so let me prepare the next question. All right, question 3, or the third, or this says 12, but our third example of arc length. I wanted to make sure I hit some with diameter. So we have an example here that gives us a diameter. And how do I know that is VS is 12, and VS goes through the whole thing. So here's how we do it with a diameter. So I am going to pick this second equation because it gives us a diameter. So this will be built into my equation where this C is. First, I got to recognize UT, the arc UT. So all I'm going to do is find this little piece, but first I have to find the measure of that. All right, so I'm going to zoom in here. I'm going to start finding some numbers until I'm satisfied that I found what the measure of this arc is. All right, so I do see that I have a half circle here. I'm going to use that 127. I'm going to say 180 minus 127. 127. I'm going to get 53. So these two pieces get me 53. So I got a 127 out here, a 53 out here. Okay, I'm not sure if that helps me yet. I'm just starting off. I always like to start with diameter. So here's a diameter. Okay, and that arc is a part of that half circle down here. Oh, I got a 90 here. So that means this is 90. So it looks like all I got to do is take this whole bottom half circle here, and if I take out 90 and 53, this will be my leftovers. So let's do 180 minus 90 minus 53 in the calculator, and I now have the piece I need. I need its arc length. And now I'm ready to set my equation up. All right, X is our measurement of our arc, and that's what I needed. So there is our X part. Our C part is put our pi in times our diameter. We already guessed that VS, well, not guessed, but we're given VS is 12. And that's it. Put your 360 in, and let's push some buttons. So I got 37 times the pi button times 12 divided by 360, and I get 3.87 for that length. Let me pause this real quick and check my work to make sure I did it right. Yeah, I put it back in my calculator and I got 3.87. That was right. It was pretty small, but there's nothing wrong with it. We don't know what we're dealing with. So this is meters, so 3.87 meters is actually not small at all. All right, so let me pause this and set up one more. All right, so this will be the last one of this video. I want to do one more with a diameter. And if you can tell, my pictures are getting a little more complex as I go. Well, not complex, but this just seems like there's a little more to each picture. All right, so JH is the segment given, and JH is a diameter. All right, so I need to know that I'm picking this second equation for my circumference. Now let's recognize and find the degree measure of the arc we're working with. So it says to start at K. So here's where my start. Go through J and in at G. Wow, it wants all of this. Okay. So what I'm going to do here is basically I'm going to try to find all this, or maybe even find this little piece and subtract it. So I want all of this blue line here. All right, so let's start working with this picture and find some information about it. I'm going to zoom in. All right. So 59 and 85 look like they could be vertical, but they're not. Okay, let me show you what actually is vertical. What's vertical are these two straight lines. And that's kind of hard to work with without. So let's make those a little smaller. Okay. All right, so those two lines are straight lines that intersect, and their vertical angles are 85. So I actually am starting there, and I can actually find my answer. So if I take a look at this picture like this, all of this is 85 and all of this is 85, meaning that if this portion of it is 59, that means this portion has to get me to 85. So on my calculator right now, I'm hitting 85 minus 59, and that's 26. And I've already found the pieces that I need. So how do I use this 26? Is that's the piece I don't need. So let me delete some stuff. Now, if you remember, the arc that it talked about and wanted started at K, went all the way around, and ended at G. So that means I can find all of this by subtracting 26, not from 180, but 360. We're dealing with a whole circle there. 360 minus 26. And all of that is 334. That's the arc measurement that I need for my formula. That was actually a pretty quick way to find it. So let me get rid of all this. And then I can set up my equation. So what I'd like you to do actually now is to go ahead. I'm going to let you try to put this all in the equation yourself. So I'm going to give you 5 seconds. You can pause it and see if you know how to set up the equation and get the right answer. All right, so hopefully you paused it and tried, but here is what the equation looks like. The degree measure of the arc is first, and that's 334. We're using pi times diameter as the C part. So pi, and they gave us the diameter, is 21. Put that all over 360, put in your calculator, and you're done. So 334 times pi times diameter divided by 360, and I get 61.2 will work. Right around 61 approximately, meaning we're rounding. All right, I hope that was enough, and I know this is tough and a lot going on, but I hope I went nice and slow and made some sense out of this.